Thank you, Robot Lady. Okay, so hey everyone, welcome to this virtual coffee lunch and learn edition. For those who are here live, you are members of the virtual coffee community. But for anyone who happens to find this recording online, this is virtual coffee. We are trying to be a welcoming tech community that allows room for growth and mentorship at all levels, make meaningful opportunities for learning, leadership, and contribution for everyone. To find out more about our code of conduct, our events, or just to learn more about us, you can check out our website, virtualcoffee.io. We are super happy to have you folks here with us today, and I especially want to thank our presenter for being here. Today, we have Mr. Simon Prickett. I want to say longtime member of the VC community, a relatively long-time member of the VC community.
Relatively, yeah.
Yeah, and I think someone who has been doing some good work in the industry for quite some time. Simon is here today to tell us all about Redis. I know for some of us, it's a name you have probably heard, but might not be aware of quite the scope of what it is, how to get into it, how to become proficient with it. And Simon is going to give us a little bit of insight there, and we really appreciate him taking the time to share his knowledge with us. So Simon, if you'd like to give a little bit of an intro and then dive right in, well, let's go.
Thanks very much. I'll just share the screen here and find that. Here we go. So we good there? Okay, so yeah, this is a introduction to Redis for application developers as opposed to other sorts of people like, say, folks that might want to install and manage a database product. And I am Simon Prickett. I'm the Developer Relations Manager at a company that is now actually also called Redis. We used to be called Redis Labs. And Redis is an open source product, and we are kind of like the steward of that. So we maintain the Redis product. We offer a cloud hosted service for it, which is how we make money. And we offer training, and that's kind of my day job. So I do what's called Redis University. You can sign up and take courses about Redis that also hopefully teach you some other things about, say, application development in Python or Node.js or Java. And what we're going to look at today is a number of use cases for using Redis, aside from the one that you possibly know about already. And we'll come on to what those are in a minute. So the obvious thing to start with is, well, what is Redis itself? It's probably something that Kirk says you've probably heard about. If you dig around at work somewhere in your stack, you might well be using it. Somebody might have put it in there for something. And what it is it's an in-memory key value data store. And it's often used as a cache because it has the ability to store stuff and set a time to live on it, and then it will forget about it. So if you want to cache something that is save on calls to backend APIs or other databases or things that generally can be a bit slow to respond or might cost you money if you hit them too much, like you've bought an API service and you want to say, get the weather for today for Nottingham, England once, and then store it for a day. You know, there's no sense getting it again later if it's a daily forecast. It's not going to change. So you can use Redis for remembering things like that. And people love it because it's extremely fast and it's relatively easy to use. And once you set it up and install it and get it doing something, it just sits there and carries on doing it. And that's part of the issue that we have here is people tend to install it as a cache and are like, great, it works brilliantly as a cache, and then forget about it, end of story. And they don't necessarily see all the other things that you could be using it for. So why this graphic? This is a woman at the Library of Congress in the 1940s. And essentially, she's using something that looks a bit like a key value data store. So if you're familiar with relational databases where you put stuff in tables and tables have schemas, so they have like an ID and a first name field and a last name field, and those might be strings, and you might have an integer field for age and so on. And you write SQL type queries to get data back or update it or insert it. Redis is in the class of key value data stores. And what that basically means is that it looks like a bunch of empty boxes, and each one of those boxes you can give a name and you can put something in it. So you can basically say, set the value of box Simon to Prickett, and you can store my surname in there, and then you can do get Simon, and you're going to get back Prickett. How Redis works as a cache is you can also, when you set it, say, hey, remember the value of Prickett in the box Simon for 10 seconds, and then forget you ever saw it. So for the first 10 seconds, when you go back and you say, what's the value at Simon, it'll say Prickett. And on the 11th second, it will say nothing, because that has magically evaporated now. That's why it gets used as a cache. So Redis is a key value store. It's unusual in that the whole data set lives in RAM, in main memory. So one of the sort of false preconceptions about Redis is, oh, everything's in RAM, so that means if I reboot the server or pull the plug or something, I've lost my database. That's not true, because when we say everything is in RAM, what we mean is all the reads come from RAM. So you can also configure it to not persist to disk ever if you just want a pure cache, but you can configure it to persist stuff to disk. So as you update values stored at keys, those can be saved to disk, and then you've got a persistent record like the database you would have in a normal database, but all the reads are always going to come from RAM. So that means if you want to store 20 gigabytes in Redis, you need a machine with at least 20 gigabytes of RAM plus the ability to run the operating system. And the trade-off for that is speed. It's unbelievably fast, because even with SSDs, RAM is a lot faster than going to an SSD or going to an SSD's hardware cache. So that's roughly what it is. This is kind of what it looks like in another way. So if you imagine each of those things on the right, those boxes have two components. They have like the key, so pig, cat, sheep, dog, parrot. We didn't quite get Skylar's bird, but I've got a bird in here. And in here, we're storing a string value against each key. So for the pig, we're storing Snowball, which if you read Animal Farm is one of the pigs on Snowball on Animal Farm, and Dolly the sheep was the first sheep to be cloned, I believe, and so on. So we can store whatever we like in here. So for a cache, we might store like the JSON response from an API or the record set from a database or something in a string. And we can run some what are called Redis commands. So the sort of equivalent language to SQL for Redis is a set of commands, and they're pretty simple. So we can say here, set cat to mocha, and we've stored something called mocha in a box called cat now, and it's implicitly a string. And then we can set dog latte, and we can get values back as you'd expect. One thing to note here with Redis that's different from other databases as well is there's no like configuration or create step here. So we didn't have to like declare that cat is going to be a box that contains a string. We just went ahead and set it, and it dealt with it for us. So quite often with key value data stores, a lot of them only have one real data type, which is strings. So you can basically store a string or a stringified object, so some JSON or whatever you want to store in there against the key, and you can get it back again. Redis is different in that it has this whole like Swiss Army knife of data types. So when you go and store something against a key, you can use a string, as we've seen already, and you can use a whole bunch of other things. So there's a list here, which is a doubly linked list. A hash looks a bit like a set of key value pairs, so a map or a associative array. A set is a mathematical set, so you can use that to deduplicate things. So if I added like A, B, B, C to a set, I would have A, B, and C in there because it would deduplicate that. And you can ask it things like how many things are in a set. And then there's data types such as the sorted set, which stores a score against value and deduplicates them. And that's often used in the gaming world to build high score tables. So you can basically say from that, give me a slice of the data where the score is between like 100 and 150, or given my user ID, give me 10 players that are scoring slightly higher and slightly lower than me. So a lot of big online games use Redis for that. It also has some other uses. So if you've ever been rate limited with an API where you've hit it too much and you get a 429 response because you're hitting it too much, quite often Redis sorted sets are behind that, and they're counting how many times your IP address accessed the thing. The red data types here are the ones we're going to look at in this core or in this talk. So the one that you might not have heard of before as a sort of data type in a programming language is a Hyperlog Log, which is an interesting thing. It's what's called a probabilistic data structure. So it's a way of counting things without using very much memory. And that's important for two reasons, because number one, with Redis, everything has to live in memory. So if you're remembering like distinct things that you've seen, so like which IP addresses have hit this website today, you are going to build up quite a big data set, and that has to live in memory. And a Hyperlog Log basically gets rid of that problem by using some hashing, and it sacrifices a bit of accuracy. So we'll look at how that works. There's also data types in here for doing things like geospatial. So I could store a bunch of locations in Redis with information about them, and then I could ask it questions like, find me all the coffee shops within 3 miles of where I am or within this box. So you can build map-like applications. And again, this will be very, very fast because it's all coming from memory. There's a stream data type that is, we could pretty much do an entire hour on just the stream data type, but it approximates to something like Kafka-like functionality. So you can put entries into a stream and you can have consumers pull them out again, and consumers can work in groups and be fanned out. Data can be fanned out to them. So you can use that as a way of connecting microservices. We're actually going to look at how to use the list data type to do that today. So if you don't like all of those data types that are in Redis, you can actually add your own. So there's what's called a module API. And if you're a C or a Rust or a programming language with C bindings developer, you can use that, and you can extend Redis to have both additional data types. So if you want to store a different sort of data in there, and additional commands. So if you want to extend the sort of query language. And we at Redis Inc., where I work, have made a number of these available, one of which adds JSON as a data type to Redis, so you can store documents in there. Another one adds a search engine in there, so you can do full text searching, and we'll have a look at that. Another one adds a graph interface, so you can write Cypher queries over the data set if you're familiar with GraphQL. Or as I say, you can write your own. So how do we interface to Redis? There's like two ways of doing this. We can use tools. So if you're familiar with SQL, the SQL world, you'll have some sort of like Toad type tool if you're an Oracle developer, where you connect to a database and you can just enter raw SQL commands. There's one of those for Redis called Redis CLI. You just enter commands and you get responses. It's quite low level. And there's a visual version of it called Redis Insight, which is a free tool that you can download, install, and point at a Redis instance. And it will give you a browser-based interface that allows you to look through the database and see things happening in real time and check out the health of the database. And we'll look at both of these as we go along. So realistically, though, as a database, you're not going to sit there and write everything in the command line. You're going to want to write code against it so that your application can use it. So as you'd expect, Redis has what we call clients, which are the equivalent of drivers for other products. And those are available for most common languages. Pretty much every programming language you can think of is going to have a Redis driver, and they're going to be open source. And in some cases, there'll be a choice of several. So with Java, it depends what style of programming you want to use. There's a couple of different ones. With Node.js, there's a couple of different ones that have some slightly different implementation ideas. And basically, they're very simple to use. So here we have a Python example up the top left and a Node example on the bottom right. And you essentially just declare an instance of the client library. And then if you know which Redis command you want to call, so I want to set something, I just do instance.set and then pass it the parameters that that command expects. So like a key name and a value. If I want to store Simon at, if I want to store Prickett at the key name Simon, I just do r.set Simon Prickett. And then you'll see down there on the right in Node, it's exactly the same, but I have to await it if I want to know it's succeeded, because it's a network call in Node. It's going to go off to a Redis server somewhere. So it's asynchronous. There's also an async Python client available if you like programming like that. So what we can see, I'll just switch here. What we can see here is I've got a Redis instance set up and I can connect to it with Redis CLI. You can get Redis from a whole bunch of places. You can download it from, download the source from redis.io and then compile it, it'll install. You can homebrew it. You can get it on Windows subsystem for Linux. You can get it in most of the major clouds. We provide a cloud for it. And you can also get it from Docker, which is actually where this one's running. This is a Docker instance. So I've got a Redis instance here, and there's a command called keys that basically tells us, hey, what's in the database? And there's nothing there at the minute. So it's completely empty. So if I was to then do something like set Simon to Prickett, we've done that. And then as you'd expect, I can basically do get Simon, and the value that we've stored comes back. I can also say expire Simon in 5 seconds. And it's still there, it's still there. I can ask it how long until it expires, and that means I was too slow, it's already gone. I say to it now, what's in Simon, doesn't know, it's gone. So that's the basic cache use case that most people will have seen Redis used for, which is like remember something for a period of time and then throw it away. And we'll look at how you implement that in an application as well. So this is the sort of lower level tool. The higher level tool allows me to browse the database. It's completely empty at the minute because that key I just created expired and went away. But I can, for example, add something. So let's do the same thing. I'll add a string and I'll call it Simon and Prickett. Now I have this key over here, and you can see there's no expiry set on this. This is just going to live forever. I don't need to know all the commands to use this interface. So if I wanted to blow it away, I can just delete it there. I don't need to know the delete command. And if I did want to drop down and just type the same things that I was typing in the terminal, I've got a sort of assisted interface here to do that. So a couple of ways of doing it if you are administering or just playing around. And let's go back to. So what we're going to cover today is quite ambitious in the time, but I'll try and get through it all. We're going to look at 4 use cases for Redis, one of them being caching, and we're not going to do that first because that's kind of the one everyone expects. So we're going to look at how we could use it to act as a queue between different processes. So say we had like a couple of microservices and we wanted them to share data between them, but they worked at different rates. And we're going to look at it for how to count things, which is a problem that looks really easy on the face of it, but isn't necessarily. We are going to look at caching because kind of people expect to see caching. Redis is used a lot as a cache. And then we're going to look at something that you probably think that you can't do with a key value data store. So the fun with a key value data store is I store everything in a key and it's got a value. And in order to get it back, I need to know the key, or I need to have some way of regenerating that key in my application, which means writing queries like the equivalent of select star from animals where species equals cat and age is greater than 7 and age is less than 9 isn't really a thing that this type of product can normally do, because you'll be storing all of the animals in a key like, I don't know, cat colon and then the cat's name or something as the key name, and then whatever you're going to store in the value. There's a module called Redis search that we'll look at, and a data type called the hash that allows us to do these sort of rich queries and full text search. So Kirk has a question, go for it.
Yeah, just before we dive in, well, Nick had a question in the chat, which was,
sorry,
you might actually address this later on, so just let us know. When you pull data out from the key value store, do you need to pass in the type as well, or do you just need to know the type when you pull it out?
That's a good question. So if you're using strings and you store, say, JSON in there, you'll need to serialize the JSON, and then you'll need to have remembered that it was JSON. So when it comes back, you can call like JSON.parse on that string to get your JSON back. or if you were using some other format, like you put CSV data in there, it's kind of on you to remember what it is, because the database doesn't care. With some of the other types, it will actually throw a type error. So if you try, let's do it. If you try something like, let's do set Simon to Prickett. So we've just created a string there, and I can say to it, what is that key's type? And it's, oh, I stored a string there. If I then try a hash command on it, which is for storing something that looks more like an object, and I say hgetAllSimon, it's going to say you can't do that because that's a string and not a hash. But if I did something like hset Simon and then like that, oops, I need to create a different key for it. Let's call it Simon hash. Then that's going to succeed. And I've now created a new hash object, which looks like an associative array. So like name value, stored at a single key. So if I try doing get Simon hash, this is going to fail because there's not a string in there. There's an associative array in it. But if I use a command called hgetAll, which is hash get all Simon hash, you'll see I get back what I put in there. And as an aside, I can also get some of it back if I only wanted some of it. So if I did, now we're going to get my last name and not my first name as well. So yeah, it's loosely typed and it cares about it sometimes, but with strings, it doesn't care. And with things like hashes, there's no schema. So if I stored a load of people objects in there as a hash and they had first name and last name, and then I added a password field to some of them, it's not going to enforce that on the other ones. So it's like schemaless in that sense. So hopefully that helps. So yeah, so what we're going to look at was, first use case is how to build a queue with a Redis list. So a doubly linked list here is like a thing in computer science. It's a way of storing a load of things and implying some sort of order, and it has a head and a tail. So generally we can push things onto the head and we can pop them off of the tail. And then we've got a way of like remembering things and getting them back in order. So if we pushed A, B, C, and D, and then popped from the tail 4 times, we get A, B, C, and D back off of this list. If you move the pop operation over to the head, you get what's called a stack, which is a way of reversing things. So if we put A, B, C, and D into a stack or a list like that, and then pop them off the same end as we push them in, you get DCBA back, and you've now reversed the contents. So that'd be one way of like building some sort of structure where the most recently thing that happened is the most important job. What we're going to do is look at a queue. So basically, queue is kind of what you'd expect when you go to the store. It's like, if I'm in front of you, I'm going to get served first, and if you're in front of me, you'll get served first, and everybody gets served eventually, and the size of the queue changes over time. So we're going to have a quick look at is, imagine we're a hotel here and we have like a housekeeping service, and housekeeping is potentially more than one person that does the jobs, and we have a front desk that creates the jobs. So you can imagine these are 2 like separate microservices or something, and in a good architecture, they don't necessarily need to know much about each other. They just need to know that I put the jobs somewhere and someone else does the jobs. So here in Redis, we have a set of commands that begin with L, and they're the list commands that allow us to model this sort of data structure. And what we do is we say here, L push, so list push, the key that we want to store the thing in. So we're going to create a list called jobs, and then any string that we want. So I'm storing some JSON because we want some structure around what the job involves. So we're going to say each job's got a room, it's room in the hotel that the job needs doing in, and what task needs doing. So hail a taxi, or clean the room, or put in some extra towels. And if we want to get those off of the queue later in a separate process, there's a Redis command for that called rpop. And what that's going to do is pop from the other side of the list, so get whatever's the like oldest thing in the list and bring it back to us, and it will remove that from the list as well. Then underneath that, there's a command called brpop, which does the same thing, but it blocks. So what that means is if there's anything in the list jobs, then return it to me immediately. Otherwise, wait for a period of time. So in this case, 5 seconds, and see if anything turns up. So we can implement a sort of lazy wait system here without our application having to poll the list all the time and say, hey, have you got a job for me? Hey, have you got a job for me? So what this looks like in Python is pretty simple. So what we're going to do is have a look at some Python here. We have a couple of processes. So we have the producer here that's going to put jobs on a list, and we have a consumer that's going to eat them back off of it again. So all I've done is just define some jobs, and this is an array that we're going to pick randomly from. We've connected to Redis, and I've cleaned up any old list that we used to have, so we've deleted it. And we create the JSON for a job as a Python dict, turn it into a string. And then it's literally a case of we just tell Redis, hey, Redis, lpush, so push that onto the left-hand side of whatever the key is, just push that string on there. And again, 2 things, there's no code here to create that list. Pushing something into the list implicitly creates it. So Redis is quite developer friendly for this. You don't have to maintain a setup script somewhere that says, oh, all of these keys need to be set up. The first time you use it, it's just going to do it for you. And that's all it does. So it'll go away and add things to a list. And then it'll actually use a different command called excuse me. So it'll use the result of the lpush command, which will tell us how many things are on the list. So when we put something on the list, it will say, great, I'll put that on the list, and there's 1, 2, 3, 4 things on there. So if I go ahead and start that running, let's go to and all of this code, I'll give you the URL for. It's free in GitHub, so you can play around with it yourselves. And there's a Docker compose for getting Redis as well. So if I start running this, you'll see what it's going to do is it's going to sit in that loop, and it's going to add jobs to this queue periodically. And we can visualize this in Redis using the Insight tool. So if I go to browser now, we should have a key called jobs. And you'll see that we've got 3 elements in there at the minute, and you can see what they are. I can also mess with them in here. I could delete them or change the values in them. And if I refresh it, you'll see it's getting bigger. So the backlog of things to do is building up in this list here in Redis. So that's my producer component. I'll leave it running. And then I have a consumer component, and this is, imagine one of the house cleaning staff or a different microservice. It's also talking to Redis, and it uses this brpop command to basically say, hey, get me the oldest thing on the list if there is one, otherwise hang out for 5 seconds and see what's what. And then when we get something back, we actually do something with it. So we get the result back from Redis, and then we're either like, there isn't anything to do, and we don't do it, and we just wait a little while and then try again. Or we get the result out of Redis and unpack it back into a Python dict and deal with it. So the cool thing here is I can run 1 or more of these. So let's do this. So this has got, we've got 18 jobs in the backlog already, and it's starting to go through them, and this is still adding them. So this is now starting to make the queue a bit smaller, and we can just basically keep adding more of these processes. So I can do and now these two are kind of working in harmony because Redis is maintaining the state of the queue. These 2 processes don't know anything about this one that's creating the jobs. They don't know anything about each other either. They're just like, give me the next job. So what you'll see is they alternate through the jobs, and we could just add as many as we want. And what we'll see is if we go back into here, the queue's now down to 7 and it will eventually get to 0, but I can also mess with it here. So, but I'm actually not going to do that. I'm going to let it play out. So at some point, this queue will get a lot shorter because things are now getting consumed faster than they're being produced. So here we've got a queue happening inside Redis in a list because of the way we're using it. And we've got 2 services, the producer and multiple instances of the consumer that are using it to talk to each other. They don't know anything about each other. And also they don't have to be implemented in the same language. So this is all Python, but one of these could be Node and the other one could be C and one of these could be whatever. And yeah, Kirk says this feels really powerful for not that much setup. There isn't a lot of like preamble with Redis. It's just like, I want to create a list. Okay, let's just put something in it. Now you've got a list. This is good and bad in that a lot of the preamble with some database products is around setting up a schema and then everyone knows what's in the database. I've kind of got a sort of unwritten agreement between my 2 services that we put something in that's a JSON object that has room and job, but I could put any old junk in here and Redis isn't going to care because it's not enforcing the schema here. So sort of with great power comes a bit of responsibility, I guess. It's like if you put junk in here, then your code needs to be able to deal with junk, or you have some sort of agreement that this is the schema for things that go in that key. And the product itself is not going to enforce that. You are. So yeah, that's a queue, which is a very, very simple thing that you can build, and it scales really nicely, and you can just keep adding things to this. If you want something that's more complicated, that's a bit like a Kafka type thing, there's a data type in Redis called Streams that has some more features. So if you had like something that got halfway through processing a cleaning job, fell over and died, and somebody else needed to have a go, then you have functionality like, okay, release my lock on that and let someone else do it. In this case, if my cleaner starts off like cleaning a room and then has some sort of issue and can't complete it, front desk thinks that job's finished. So the simple list isn't good for that scenario, but the Redis stream would be. So that's lists. Moving on from that, and sort of interesting problem that is a whole other talk that can go on for an hour on itself, is counting unique things. So everyone thinks this is really easy, right? We all know how to count like 10 fingers and all of that. But if you need to count distinct things, you've kind of got a problem. So if you need to remember like all the different car license plates that drove past the camera in a day, you've actually got to remember them all one way or another to know that when the next car drives past, it's a new car and not one that's already been passed today, and then you need to add one to the count. So there are some issues with that, because if you're counting things and having to remember them, and especially if you're using a product where the data set lives in memory, then you have got a sort of runaway data issue. So if I am counting things, I don't know how many of them there's going to be, and they're quite large, they're like huge UUIDs or something like that, then eventually I'm going to run out of memory just from storing them. So there's 2 ways that we can do this with Redis. This is a really boring slide and I apologize for it. There's a set and there's what's called a Hyperlog Log. And if you did math, and I'm not a great math person, but I think I can remember this. The way a set works is that you put things in it and you're not allowed duplicates. So you can keep putting, say, car license plates in a set. And if you put the same car in 3 times because it drives past 3 times, it's only going to count once. And then you can ask the set, how many things have you got in the set? And it will say, oh, 23,455. And it will be absolutely accurate and it will be right all the time. And that's brilliant, unless you're doing this at big scale, or you're doing it at small scale and you've got a lot of things you want to count. So say if you're a big website and you're counting like the number of different articles I've read today on Medium for all of the users, then this solution may not scale. So there's something else called a Hyperlog Log, which is a like probabilistic data structure. And these things are fascinating, but it basically boils down to, instead of storing the data, which is the problem here, you hash the data down into a smaller representation of it and you store that. And with hashing comes the possibility for clashes. So like my license plate and your license plate might actually hash to the same value in some cases. And then we've lost a car because I can't tell the difference between your car and my car anymore. And it also means I can't ask it for a list of all the license plates we've seen today, because once you hash it, that data's gone away. It's become this like smaller bit representation. However, there is a huge advantage, especially when you're doing this at scale, and a little bit of an error is okay, and that's a space requirement. So if I'm hashing stuff down and I'm using the Hyperlog Log algorithm, I can count a huge amount of distinct things and I can be pretty accurate, and I'm going to use 12K in memory. Whereas if I used a set and stored all of those things, I could use megabytes and megabytes and megabytes of memory. So for some things, like imagine if you're Medium and you're storing, has Simon read this article before? And you have, or sorry, how many articles has Simon read before? Or how many likes does this Twitter post have? Being 100% accurate isn't that big a deal, because you can say like 13.7K and it doesn't really matter if it's 13713 or 13799. If you're using a set to measure all of the usernames that have liked that post or liked that tweet, then you're going to be storing all of those per tweet, and you've got a major storage problem. If you're using something like a Hyperlog Log and approximating it, then sure, you give up a little bit of accuracy, but you're going to be using like 12K, and it's a lot more manageable. So the Hyperlog Log's built into Redis. It's an unusual data type to have in there, and it's partly to do with the history of the product, as it was built by one person originally, and he kind of put in a grab bag of things that he thought was useful. So there's like all of these data structures, and this is one of them. So how does it work? We can have a look at that in some code, and this example's in Node. So kind of the point of this talk as well is it doesn't really matter what programming language you're using, they're all equally accessible, or Redis is equally accessible from all of them. So we're going to do some counting of unique things. So I've just got a big file of unique IDs that were generated by a unique ID generator, and there's about 500,000 of them or something like that in here. So what we want to do is try counting all of those two ways in Redis and comparing how it looks and how much memory it takes. So we're going to use two different keys. We're going to use Hyperlog Log demo and set demo, and we're basically going to read that file and put them into both of those data structures. So the interesting thing is the way that you talk to these data structures is about the same from a programmer's perspective. So the set commands all begin S. So sadd adds something to a set, and we say, what's the key name and what are we going to add to it? So I'm adding a whole load of things at once because we can add like A, B, C, D, E as a single command. And the Hyperlog Log begins with PF, which is the initials of the mathematician that came up with it, and a different key name and the same payload. So if I'd started writing an application using a set thinking this is great, it's going to be perfect, and then I find I've got a memory problem, swapping the Hyperlog Log in is really easy. It's like a single command change. So I'm going to go around that, read all of these IDs, and then at the end of it, we're going to ask Redis some questions. So we're going to say, hey, Redis, what's the count on the Hyperlog Log? How many things did it see that were different? We're going to ask the set, what's the cardinality, which is the like set theory word for the size of it. And then we're going to ask Redis for both of these, how much memory are you using to store the value at these keys? And what we'll see is the Hyperlog Log's a little bit wrong, but it's in the right ballpark, and there's a dramatic memory difference. So if I go to here and come out of that, and we just run this code. So this is a Node application, basically same simple programming interfaces Python had. It's offloading 500,000 things into Redis, or however many there were in there. There we go. And what we can see is that, as you'd expect, the set is 100% right. And in some cases, this is important, right? So if we're counting the number of people who voted in an election, this is probably the right answer. We want the right answer. But the cost here is we've used like 24 megabytes of RAM to do that. And this is a relatively small example from internet scale. So if we were counting like something to do with visits to Google or something to do with Twitter, this would be a problem very quickly. The Hyperlog Log, however, says it's seen 498,384 of those things. So it's had a few where they hash to the same value and there's been a clash and we've lost a few, but we're in the right ballpark and that's good enough for a lot of situations. So how many people like this photograph on Instagram? That's good enough. 498K versus 500K. And the trade-off here is we used exactly 12K of memory. So we can store a lot of these in that 24 meg that the set took up. So yeah, there's a lot of probabilistic data structures are very interesting things to play around with because they involve trade-offs and being wrong sometimes, and sometimes being wrong, it turns out, is actually okay. But again, same thing with Redis. We didn't create a set or declare a Hyperlog log. We just added things to it and it did it for us. And that step wasn't necessary. So third use case is caching, which is the one that if anyone's used Redis, I would put a lot of money on. This is what you've used it for one way or another. You've either built some logic that does it, or you've configured a framework that does it for you to use Redis as a cache. So basically, there's a couple of reasons why you might want to cache things. Redis is fast. Your other database probably isn't, relatively speaking. So if you want something to be very quick and you've made a database query recently, and there's a strong likelihood that that query will return the same result if it's made soon after you did it, then you can use a cache. So you store the result of that for a period of time. You look in the cache first, and if it's not there, you go to the database. And if it is there, you use the cache version. So like stock prices, for example, you might want to cache for a couple of seconds because they change over quickly. Weather, you might want to cache hourly. What else? Top 10 news stories on your website, you might want to cache for a little bit longer than that. But anything that allows you to save the result of a computation and do it again later. The other way you can use cache that people don't always realize is you can save money. So if you have bought a third-party API service, so say your product calls a weather API or something like that, and you're doing it a lot, then you're going to burn through your allowance and you're going to incur costs, or you're going to start to get rate limited and not be allowed to use it because you're not sharing nicely with everyone else. So if you can use a cache to stop making some of those calls because you've seen that you've made them before and you already know the result, or you know a good enough result, then you can save money by introducing a cache component. So we're going to look at caching an API response, but this could be a database call or anything else you want to cache. It could be a web scrape of a HTML page. And basically without that, you're just going to go straight to the thing that you want to access, call it, and get a result back. So that's pretty simple. You just call an API. And then one way we can implement a cache with Redis would be to change that logic to say, hey, don't call that API straight away. But let's have a look in Redis and see if we've got the result. So if we're calling the API for like the weather at, say, Nottingham, England, and that's part of the unique thing for that API call, we might store a copy of that in Redis, and we might use a key name, something like weather : Nottingham : England. So we can figure out next time where we stored it. So when we get another request for the weather for Nottingham, England, we say, hey, Redis, have you got anything in weather Nottingham, England? And it'll either say that's empty because it doesn't exist, or yeah, I have. And if you have got it, then you should return that and save yourself a call to the API server. If you haven't got it, then what you should do is go call the API server, send the result back to the user, and then when you're finishing up in your API route, you should store that in Redis and say, hey, Redis, remember this for a period of time. And that period of time will depend on your application needs and how long, how current the data needs to be. So you can use a command called setex, which is set and expire. So we'd say setex weather : Nottingham, like 60 seconds to store it for a minute. We'd probably store weather for longer than that. And then the value would be that JSON document that you got back. So next time it comes around the loop, the get succeeds and you get a much faster response. So we can look at how that looks as well, which is in my case a Java example, but again, same thing applies to anything. So here we've got an application that we are going to call an API that gets a currency conversion rate. Doesn't really matter what the API is. And the Redis client for Java that we're using is called Redis. So we've just created an instance of that. And it's the same deal as all the other languages. So you do Redis or Jedis, if you want to pronounce it that way. And Redis dot the command name, so get, and you work out what the cache key is. So in our case, it would have been like whether : Nottingham or whatever, something that we can identify that API request with. And if we get nothing back, then it's the sad face. We didn't have anything in Redis because either we've never requested this before or requested it a while ago and it's expired. So we need to go call our exchange rate API or whatever we're going to do to get a value. And then what we need to do is set that in Redis. So I'm using that setex command, again, giving it a key name, saying how many seconds I want to store it for. That's 15 in my case, and then the value that I'm storing. So what happens then is we print out the value wherever it's come from. And then the next time we're asked to do this, if we're within that 15 seconds, what's going to happen is we'll do get, rates will come back as non-null, and then we can basically say, happy face, we got a cache hit, and return it. So this will save us money and rate limiting on this. But the other thing it's going to save us is quite a lot of time. So if we look at here and I do, and I run this code. So the first time I run it, 364 milliseconds, and we got it from origin. So we went to the API server. If I run it again, 51 milliseconds. So that's already what, like 6 or 7 times faster, just getting it out of memory in a Redis server. Even if that Redis server is somewhere else on your network, it's going to be a lot faster than doing a DNS lookup, making an API call, waiting around for them to do whatever, and then coming back. And if I wait a little while longer now and run it again, we're back to 332 milliseconds because I'm over that cache time. So Redis forgot about it. So nothing in your application forgets about it. I'll call it again. It should be fast. There we go. There's nothing in your application that says, hey, did the time pass? Your application doesn't have to track that. That's happening in Redis. Again, if I go here and we got a slow one, and then I go look at my database and I'm fast enough, there we go. Here's my key. Here's the value. It's going to disappear in 9 seconds. So the data store is tracking this for us. Application doesn't have to. So again, lots of things can use this cache and share values that are in there, and they don't have to know about when it's expired. So if we do that now, something went wrong because that doesn't exist anymore. And when we refresh here, it's gone. So that's the use case that almost everybody uses Redis for one way or another. You're either putting some logic in your application, or you are configuring a framework such as Spring or Express, if you're a Node user, to do this for you. So finally, I sort of said earlier, the sort of elephant in the room with key value data stores is everything's great if I know the key or I can work it out. So if I'm using like whether : Nottingham and my AP, my route for that looks like something that gives me the word Nottingham, and I know that it's weather by the time I've got into that function, I can build that key name up, and that's great. But what I can't do is sort of SQL-like queries across multiple things. So I said earlier, Redis is extensible. There's a module called Redis Search that we at Redis Inc. make. And you can use this to help solve this problem and do things that are very, very fast that you wouldn't normally expect to be able to do with a key value data store. So we're going to look at this with an example of some animals and the hash. So we actually looked at the Redis hash a little bit earlier with Meg's question about types. Remember, I put first name and last name as fields into a single Redis key that I called Simon hash. And then I can store a flat object-like thing in a single key. So if you imagine I am an animal shelter and I've got a whole bunch of animals that are available for adopting, and I want a website that's really fast, and I want some, faceted search over that, then Redis wouldn't normally be a product that you might consider for that, because you've got to store the animals against a key name. So here I've chosen to give all the animals an ID and a prefix adoptables, just to keep them out of the way of other things. So adoptables :1001 is a hash, and in that hash we're saying there's a field called name, and his name's Charlie, and species, he's a dog, and he's 13 years old. And then adoptables 1002 is a 9-year-old cat called Luna. And this is great if we're referring to everything by the ID. So I can do get all adoptables 1001, and I'll get everything about Charlie. Or I can ask it just for Charlie's name, or Charlie's name and age and his weight, and I can add a new field called weight, and that won't apply to Luna because there's no schema here, so the other instances don't care. And all of this is brilliant if I'm accessing it via adoptables :1001. So this makes for a terrible website experience. So if I built a website that said, here's all the animals we've got, 1001, 1002, 1003, and then you had to drill down to get the details, that wouldn't make sense. So you can't retrieve data by non-key fields normally in a key value data store. So things like this should be impossible. So we shouldn't be able to find all the pets called Luna without building some other data structure that has Luna as a key and then points at this hash or something like that. So we'd be building all of this other stuff in the database. And we'd certainly have trouble with things like find pets in the 7 to 11-year-old age range, or find pets that are safe with children in San Diego, California that are 9 years old. Normally, you would not expect to be able to do that. By using the Redis search module, you can. What we're going to do here is break a rule that I said earlier about there are no create steps and there are no schemas. So when we're doing this sort of searching of data, we do actually need to tell the data store a little bit about what's in those hashes, because it's got to be able to have some intelligence about them to do certain types of queries. So if I go to here, we'll see I have a load of animal data. So it's just Redis commands here. So we have adoptable 102 is the key, and then this is a dog called Alfie, and he's 3, and he's weight 11, and he's a male, and he has a fee of 20 whatever currency units to adopt him. And then there's some information about Alfie that's free text. So Alfie needs help with house training is a thing to note. And we have loads and loads of these animals, and they're dogs and cats. So we're storing them all in Redis hashes. And as I was saying, the only way we can get back to them normally will be through this number and this name. So what we're going to do is use Redis search and create an index. So this is the first time we've actually created anything in Redis manually as a create step that doesn't just store data. So this is defining a schema for these hashes. And we are basically saying here that look for everything that has a key that begins with adoptable and is a hash. And then for each field in there, we're just saying what it is. So the name is text and we want it to be sortable. The species we're saying is tag, so we can facet it. So they'll be like dog and cat. We're not defining what the values are. We're just saying it's a tag. It's a distinct set of values. Age is a number and so on. And then we have location is a geo, so it's a lat long point. And description is free text. So what Redis search does is it allows us to build an index on a bunch of hashes, and then it gives us an extra query language to ask questions like, give me all the dogs that are house trained and between 7 and 9 years old. So if I load this data up, that's fine. That error there is just because we're deleting an index that didn't already exist. So we should now have loads and loads of keys in Redis here. So each of these, so adoptable 128, this is a dog called Rex, so fairly stereotyped dog name there. This is Rex's location, which shelter he's in. He's a male, he's good with children and other animals, and he costs 30 currency units, and he's 5 years old and weighs 26 weight units. So now to build like a compelling website or search experience, we need to be able to do more things than just say, I want to know about 128. Oh, cool, he looks good. So Redis search also comes with a query language that we can see here in Python. So here I've got a Redis search client for Python, which again is very easy setup. We just basically tell it what index we want to look at. So we call that index adoptables. And then I can ask it some simple questions with a single function called search and a query language. So find anything that's got Luna in it. We don't even need to say what the field is, just Luna, it's going to find that. So if we had a dog called Luna, it would find Luna. If we had a dog that's friends with Luna, like they're a bonded pair or something, and that's in the description, it'll pull that one back as well. We can then ask it questions like of the tag field. So we set species to be a tag. So we use an @ for that and then a value in here. So we can say, I want everything where species is equal to dog. And then we set age to be a number, and I can say, and I want it to have an age between these two values. So all the dogs between 9 and 15. And then we can get really complicated and do things like, I want all the cats where the children field is yes, so they're good with children. And this is where sort of overlapping with Elasticsearch type products comes in. And the description does not contain the words anxious or nervous, because, you know, we want a cat that's super good with children and isn't going to get stressed. And so we can now ask this data set that normally in a key value data store, you're just not going to be able to access this way, all of these rich questions, and we could build a really cool website. And I can even do things like your normal adoption form you would expect to be like, put in the criteria and where you are. So I can say, I want all the dogs that are male, and here is my location, and I'm prepared to travel up to 50 miles. And Redis search will look in all of those hashes, look at all the locations and find everything that's in that area that also is a male and a dog. So if we run something like this, let's just change this down here to call this one. Then what we can expect to see back is basically the documents that we stored in Redis. So if I then do query index, oops, I need to activate the virtual environment. There we go. Then this is basically a printout of all of our dogs that meet those criteria. So these 23 dogs are in the right area. They're all in the right age range, whatever we said that was. Let's get rid of that. Did we say an age range? No, we didn't. We just said male and dog, and within that area. So these are the ones that match. And if we'd have put in keywords like, you know, minus anxiety, we wouldn't have got this one back, for example. So we can do a full text search. This again is all coming out of RAM, so it's extremely fast. So if you wanted to build like a some sort of web experience for searching and faceted searching, that's very, very fast. And also where the data changes quickly because the indexing is done in RAM. So if I go and change one of these hashes, it will re-index it. And then I get different results almost immediately because there's no like huge re-indexing time because it's all in RAM. It's watching for changes on these hashes. It'll update the index. And then in terms of what this looks like in Redis, it's just basically a bunch of hashes. So our application doesn't need to know that we've put a search index or a schema over it. Our application that, for example, people use to write, you know, new dogs into the system can still just be setting Redis hashes like it always used to do. And we've added all of this extra functionality on top of it without the create step for the data doesn't need to do anything because this indexing process is running on the server in the background. So that is kind of, I think we're about out of time as well, but that was actually all the content that I had as well. So the takeaways from this are Redis is an in-memory data store. It's very, very fast. It is durable, so don't be scared of in-memory. You can pull the plug and you'll be fine. And it does a lot more than caching. And if you'd like to learn about it in a more structured way, then my day job is running university.redis.com and developer advocacy at Redis Labs, or no, Redis Incorporated. We changed the name. And here we teach, everything we teach is relevant to open source Redis. So we are not actually selling you anything, but of course, we'd also love you to come and use our Redis cloud if you want a hosted version of this that we can scale and manage for you. But if you want to take it all, run it open source and deal with it yourself, then we have education materials for that too. So thanks for attending. I'll just have a look in the chat, but I don't know if we have any other questions, or does anybody have anything? Feel free to unmute and jump in.
Just before we kind of jump into the questions, Simon, that was great. I really appreciated that, especially I love how you mixed in the different languages, and it felt really approachable. As someone who really did not know too much about Redis before, this felt really, really good. And you know, I'm at the point now where I'm like thinking through stuff at work and like, oh, is this a use case for this? Which I feel like is a place to be after a talk, just like having enough context to be like, maybe this is a good decision for some of our problems. So,
yeah,
excellent.
If anyone's interested in more stuff, I mean, obviously we have a university which teaches you about the product, and that's kind of on a schedule, and the next courses start in October and you can sign up for them next week. We have a developer site that's more just there's stuff on there that's lots of example projects, and all the code for this talk is available there, and I'll post it in the Slack afterwards as well, so everybody can see that. We have a Discord that you can chat on, and you can just hit me up as well. I'm in Virtual Coffee Slack, so
yeah, I think so. What we'll do now is I will say sort of the official thank you again for the talk, and just to let everybody know and everyone watching that if you want to present a lunch and learn like this, we have a forum in the VC Slack. Any member is welcome to submit a proposal for a lunch and learn, and we always try and accommodate. But yeah, I will open the floor for anyone who has any questions, comments. Feel free.
Yeah, I was curious, Simon, for the university, the curriculum that's starting in October. What's the cadence of it, or is it learn as you at your own pace, or is it like structured classes? Like
so it's we have like 8 different courses on different topics, and they run for 6 weeks. And basically you could complete, it's self-paced, so you could complete all of it on day 1, or you could take the whole 6 weeks, or you could work work your way through it. And it's based around, it's all video training online. They all have GitHub repos. Everything is open source Redis, so we're not selling you anything. And you can earn a certificate that you can stick on LinkedIn, and basically all the questions to earn that are multiple choice ones where we're not trying to trick you. So we'll be like, you know, there is pick any 2 of the following answers or whatever. And quite often it's stuff that you can work through with a data set in an example Redis instance that we'll give you in the cloud. Or on the programming ones, there are some programming challenges, but those aren't scored. So if you didn't want to do the programming or what have you, then that's not a requirement to be successful. It also makes my life easier, because like grading everyone's coding exercises would be difficult. But we do welcome like discussion about those in Discord and stuff. So if you get stuck with one or don't understand it, we can help you. And we are looking at some other learning paths, around potentially streaming some of this and having office hours and things like that.
Cool. I had another question about how you're showing with the indexing, where we're creating the data there. You can query the data in different ways. Like you said, there's like a SQL driver and stuff. So if you were to use the SQL approach, can you do it like a regular query, like find, would you say like find animal where name is Luna, or is it, or you don't even need to?
Exactly. So you do have to use the query syntax for it, because it's not as such SQL. But if you had like an existing or a new data set in hashes, and you put a thing over it, these are not
Okay.
related to this index. Then we have a tool here that helps with that a little bit. So I can basically do, so if I just search for Luna, I'm going to get that thing and it's showing me where it is, its name and description, right? But if I did something like, let's see. I'm not going to remember the syntax very well here. I think just putting them together is something like, if I did something like Luna species, colon, dog, then now I'm not very good at this. The syntax for this, but you get the idea. Is like I would be able to say, oh, Luna where it's a dog, and we don't have any Lunas where it's a dog. But also the sort of big thing to point out from here is that you can use this for both faceting. So things like, get me all the dogs, or if you're a appliance company, get me all the refrigerators, but you can also use it for full text search, so like Elasticsearch. So you can say, get me all the refrigerators where it does not say like ice in the description, or where it only says ice, or where it says crushed ice. And it's pretty powerful. It will also do things like, if you're searching through user reviews, you're gonna have spelling mistakes. So it'll do like fuzzy matching. So things that sound like crushed, it's capable of doing that. So I'm not sure that's a great answer, but I kind of, this module does two things. It does sort of faceting and full text search.
Yeah, no, it's fine that there's like a custom query language. And like you showed, I mean, you can abstract that away anyways. Like you know, whatever you're writing, you could have like a, find animal where the name is dog, and then just pass that under the hood into the actual query text. So
yeah, and you can like basically build these things up all day. I have a better code base somewhere that has functions that return things like must, you have a function like must contain that would return description anxious or something, if it was must contain anxious, or must not contain, and then it would build that up for you, and then you just chain them together in a nicer way.
Okay.
I was trying to keep the size of the code down in this case, so it's all kind of inlined in here, which is probably not how you do it for real, but
yeah. But no, appreciate the talk. Thanks.
Cool. Thank you.
Turn my camera off so no one would see me stuff meat pies into my face. Yeah, I mean, I don't know. I really, and you mentioned that it's a double-edged sword, but I do think like the power here is how approachable this is. Like, it feels like you're just one module import away from having like all of this at your fingertips. And there's a bit of due diligence with that, but for a lot of like straightforward use cases, where like the data coming in is of a certain type, and what you need is of a certain type, where like having a schema on top of that will not necessarily add too much. This just seems really, really useful.
The sort of having a schema versus not having a schema is also a little bit more of a challenge depending on your choice of programming language. So the more strongly typed your programming language is, and the more you have to define objects, the more that's going to be something you have to think about. But in something like Node, it's just like, oh, just create me an object out of this thing. And then you can just, use has own property or whatever to check if it's got something. But yeah, there's nothing going to be, so if I created a new field on all of those animals and called it something like the date that we received the animal into care or something, and I didn't bother putting it in some of them, Redis doesn't care. So yeah, we're not going to enforce that. That also means that when I do that, I don't have to go around and rewrite all the logic everywhere in the system that deals with database to say, oh, now we've got this new field, and like if it's there, you need to add it, and what do you do with it, and so on. So does Elm have a, let's see.
I don't know.
So over here, there's
I feel like there's TypeScript types already for this.
possibly, yeah. We are working on a new version of the Node client that uses TypeScript extensively. And and also does a bit more translation between like what Redis returns, which is often an array of arrays, and what you actually want, which is probably an array of objects. But yeah, if you're working in any of those languages, there are clients for Redis, and also we publish the protocol. So if you don't want to use a client, or you're working on something really, really little like an Arduino or something, then there's just a wire protocol that you can send things to it and get things back.
Nice. Cool. Yeah, no Elm, but I didn't think so. But I see Haskell there, and C#, so by default, F# can use it too. So if it's, it's already on the .NET ecosystem, and yeah, looks pretty good.
Yeah, and we currently have courses for JavaScript, Java, and Python. And we have somebody working with us now that does C#. So maybe we'll have some content for .NET in the future. But basically, if you can understand the commands, and every command is listed out here, and you know what the commands options are. So say we go for like hashes, and I pick this one. That's a bad example because it doesn't have any options. There we go. Then the way I'd call this from most Redis clients would be client instant.h exists. First parameter would be key. The second parameter would be field. And I would expect a 0 back if that field doesn't exist in that hash, or a 1, or in some cases, the client might translate it to a true false for me. And that's kind of how it works in all the languages. So once you've got your head around creating an instance and connecting to the data store, then running each of the commands is kind of as easy as just looking it up and figuring out what things you need. There's also some fun stuff for creating, say, gaming experiences or whatever. So if you want a random field out of a hash, like you had, like you're building, I don't know, say a top trumps game where you have like a load of cars and they all have properties like horsepower and number of wheels and engine displacement. And you challenge somebody to be like, the engine displacement on my card is bigger than yours. Then you can have Redis pick a random one of those fields for you and sort of build a fairly dumb automated player. Or if you want it to run price draws, you can put things in a set. Like we could put, I have an example that puts everybody's GitHub ID that registers on a web page into a set. And then we use srand member to randomly pick one out and you win a prize.
Nick said that as a joke, but now I'm thinking about it, and that's dangerous.
There's probably plenty of other client implementations you could use as the basis as well. But
yeah,
it's hacked over fast.
I'm a big fat nerd. I want to do it. But yeah, so I think if we don't have any more questions, what I'm going to do is I will stop the recording. I can hold the room around for a little bit if folks want to chat. But otherwise, I will say, yeah, this was, Simon, you should probably consider teaching people about Redis for a living because you're really good at it. Just,
you say that, yeah.
Throwing the idea out there.
So if I'm allowed to plug one thing, it won't be anything commercial, but do check out our Discord. It's discord.gg/Redis. We talk about all things Redis, and there's at least 3 of us in the virtual coffee community that work for the company that produces the product, but I'm sure there's lots of other people that use it as well. So ask around and get a counterpoint from somebody that isn't paid to talk about it. But
we use
one of the biggest problems we have with it is people put it in to do one thing, it works, and then the problem with things that just work is they're never a squeaky wheel and no one investigates what else they can do or anything. So yeah, our big thing is awareness, really. Try it out. If you need things to go fast and you like shared data structures, then probably the right answer.
Redis is like the pant zipper. No one thinks about the zipper in their pants until it's broken. And then it's the most important part of the pants. That's the wisest thing I'll ever say.
That's a almost not safe for virtual coffee reference, but yeah.
Oh
And
wait,
Velcro.
we
Redis is
on
like
here.
Velcro. It's just faster. Velcro.
We have a crowd on both sides of the Atlantic here, so pants carries a double meaning. You're right. That's my fault. Trousers for my my friends in the UK. I apologize.
Yeah.
Okay,
But yeah,
Well,
folks.
we can talk.
I think we use like Swiss Army knife, or the actual logo is a shape sorter, because essentially it's just a box that you put things in, and things have some degree of typing when they need to, and they don't when they don't, which is why they're shaped.
Okay, before I forget, so once again, Simon, thank you very much, and folks,
Yeah, thanks. Yeah.
you doing, and